Hi friends, today I am giving a lecture on algorithm for deep search, that means depth search in data structures with example problem. It is one of the most important graph traversal technique. So graph traversing means visiting all the vertices of the given graph exactly once. That is called as graph traversing. There are three types of graph traversal techniques are there. First one is DFS, and second one is BFS, and third one is D-search. In the previous videos, we are already discussed about algorithm for DFS with one example problem and algorithm for BFS with one example problem that we are discussed in the previous video. Now in this video we have to discuss about algorithm for D-search with one example problem. Okay. Now this is the algorithm for D-search. So algorithm D-search of V. V is nothing but starting vertex. Okay. So this is the given graph. In this given graph there are 10 vertices are there. So now vertex 1 can be treated as the first vertex. Okay. Algorithm D-search of V. V is nothing but starting vertex. Next, brace begin U is equal to V. So V is nothing but vertex 1 that can be assigned to U. So now place V in the stack. So vertex 1 is inserted into the stack. Okay. Now visited of V is equal to 1, means visited of 1 is equal to 1. Okay, that means vertex 1 is visited. Okay, now do brace begin for all vertices W adjacent from U do. Okay, what are the adjacent vertices for U? That vertices can be treated as W. Okay, find out all the adjacent vertices for vertex U. So that adjacent vertices can be treated as W. Okay. If vertex U has the adjacent vertices, now this condition is true, then go to the for loop. Okay. Brace begin if visited of W is equal to 0. Okay. Now here we have to check the adjacent vertices of U. So visited of W is equal to 0. So we have to check the vertex W is visited or not in this step. If it is not visited, then go to the if block, add W to the stack. Okay. So vertex W can be added into the stack. Now visited of W is equal to 1. Now vertex W can be visited. Okay, so now again we go for second vertex W, adjacent vertices of U. So second W contains more than one vertex. Now again we have to check if visited of W is equal to 0. If the condition is true, then add W to the stack and visited that vertex. Okay, whenever this condition is false, then go to this step after the for loop. Okay, if stack is empty, if the stack is empty, return nothing, otherwise else delete topmost element from the stack. Okay, so this procedure is repeated until false. So this is the D-search algorithm. Okay, now we go for example. Find out the visiting order sequence of vertices for the above graph using D-search. Here this graph is a undirected graph because each and every edge is not directed. Okay, now this graph can consist of 10 vertices. Initially all vertices are unvisited. Unvisited can be denoted by visited of 1 is equal to 0. Visited of 1 is equal to 0 means vertex 1 is unvisited. Suppose visited of 1 is equal to 1 means vertex 1 is visited. Okay. So Initially, all the vertices from vertex 1 to vertex 10 are unvisited, so that visited of 1 to 10 is equal to 0. Whenever it is visited, visited of that vertex is equal to 1. Okay. Now, go to step 1. Example, algorithm D search of V. So, V is nothing but starting vertex. So, here starting vertex is 1. So, algorithm D search of V is nothing but D search of 1. Brace begin. U is equal to V. That means vertex 1 can be assigned to U. So, now U is equal to 1 and V is equal to 1. Now, V value can be inserted into the stack. Place V into the stack. So, now stack contains vertex 1. Okay. Now, visited of V is equal to 1. So, previously visited of 1 is equal to 0. So, now visited of V is equal to 1 means visited of 1 can be 1. Okay. Now, do brace begin for all vertices W adjacent from U. Here U is equal to 1. Now, find out the adjacent vertices of 1. So, 1 adjacent vertices are 4 and 2. Okay. So, now W is equal to 4 and 2. Yes, vertex 1 has the adjacent vertices 4 and 2. This condition is true. Go to the body of the for loop. Okay, here W is equal to 4. One for loop iteration is going on. W is equal to 2. One for loop iteration is going on because W is equal to 4 and 2. Now, first one, if visited of W is equal to 4. So, visited of 4 is equal to 0. Yes, visited of 4 is equal to 0 here. Okay. So, condition true. Then go to the if block. Add W to the stack. That means add 4 to the stack. So, now 4 can be added to the stack. Okay. Now, visited of W is equal to 1 means visited of 4 is equal to 1. So, now visited of 4 is equal to 1. Now, brace close. Again goes to the for loop. Here now W is equal to 2. Okay. So, brace begin. If visited of 2 is equal to 0. Yes, visited of 2 is equal to 0. Condition true. Now, then go to the if block. Add W to the stack. That means add 2 to the stack. So, now the stack contains also 2 into the stack contains now 1, 4, 2. Next, visited of W is equal to 1. W is equal to 2. Now, visited of 2 is equal to 1. So, now visited of 2 is equal to 1. Okay. Next, again goes to the for loop. At vertex 1 has only 2 adjacent vertices 4 and 2. Vertex 4 is added into the stack and visited, and vertex 2 is added into the stack and visited. Okay, now this condition is failed, then the control goes to the after the statement, after the for loop. Okay, after the for loop, control goes to this statement. If stack is empty, no, stack contains 3 elements 1, 4, 2. Okay, so this condition is false. Go to the else. Delete top element from the stack. What is the element is there? Top element is there in the stack. So top element is 2. Now delete 2 from the stack. So delete 2 from the top of the stack. After deleting 2 from the top of the stack, so now the top of the stack points to only 4. Okay. So now whatever the element that is deleted from the top of the stack, next step starts from D search of 2. Whatever the element that is deleted from the top of the stack, step 2 starts with that vertex. So that is algorithm D search of vertex 2. Okay. To D search of 2. Okay. So algorithm D search of 2. Now V can be assigned to U. So that means U is equal to V is equal to 2. here placed V in the stack. This is the first time we have to done. So the remaining vertices there is no need to follow. Okay. So U is equal to V is equal to 2 by assigning V value to the U. Okay. Now visited of 2 is equal to 1. That is already is there. Visited of 2 is equal to 1. Next, do brace begin for all vertices W adjacent from U. Here U value is equal to 2. What are the adjacent vertices of 2? So that adjacent vertices can be assigned to W. Okay. So now U value 2. What are the adjacent vertices of 2? 1, 3, 5, 7, 8. So 1, 3, 5, 7, 8. Here W is equal to 1, 3, 5, 7, 8. Okay. First W is equal to 1. So brace begin. This condition is true. Vertex 2 has the adjacent vertices 1, 3, 5, 7, 8. So among them first W can be taken as 1. So brace begin if visited of W is equal to 1. Visited of 1 is equal to 0, false. Here it is visited of 1 is equal to 1. So this is false. Okay. So there is no need to go to if block. Again control goes to this one. Now W can be taken as 3. Okay. So brace begin if visited of 3 is equal to 0. Yes, visited of 3 is equal to 0. Condition true. Then go to if block. Add W to the stack. So now 3 can be added to the stack. 3 can be added to the stack. Next, visited of 3 is equal to 1. So visited of 3 is equal to 1. Again control goes to this one. Now W is equal to 5. So brace begin. Visited of 5 is equal to 0. Yes, visited of 5 is equal to 0. Condition true. Then go to the if block. Add W to the stack. That means W value 5. 5 can be added to the stack. Okay. Next, visited of 5 is equal to 1. So visited of 5 is equal to 1. Next, again control goes to the for loop. Here now W can be taken as 7. Okay. So brace begin. If visited of 7 is equal to 0. Yes, visited of 7 is equal to 0. So condition true. Then go to the if block. So add W to the stack. Now W value 7 can be added to the stack. Next, visited of 7 is equal to 1. So visited of 7 is equal to 1 now. Okay. Next, again control goes to for loop. Now W can be taken as 8. So brace begin. If visited of 8 is equal to 0. Yes, visited of 8 is equal to 0. Condition true. The control goes to the if block. Add 8 to the stack. So now W value 8. Add W to the stack means 8 can be added to the stack. Next, visited of 8 is equal to 1. So now visited of 8 is equal to 1. Okay. So again control goes to for loop. So there are no adjacent unvisited vertices. 1, 3, 5, 7, 8 all are completed. There are no adjacent vertices for U. So this condition is false. The control goes to the statement after the for loop. Okay. Now control goes to this statement. If stack is empty, no, stack is not empty. Okay. So then go to the else block. Delete top element from the stack. Here top element is 8. Okay. So delete 8 from the stack. Okay. Now call dsearch of 8. Whatever the element that we have to delete from the top of the stack, then call dsearch of that element. Here dsearch of 8. Next we go for step 3, dsearch of 8. Now after deleting 8 from the top of the stack, this is we are getting. Now call dsearch of 8. So now dsearch of 8. So algorithm dsearch of V is nothing but 8. So brace begin. U is equal to V. V can be assigned to U. So now U is equal to V is equal to 8. So next, visited of 8 is equal to 1. Already visited of 8 is equal to 1. There is no problem. Next, do. Brace begin. For all vertices W adjacent from U. Here U is equal to 8. What are the adjacent vertices of 8 is there that can be treated as W. So 8 adjacent vertices are 2, 5, 7. So now W can be taken as 2, 5, 7. Okay. So now this condition is true because U is nothing but 8. 8 has the adjacent vertices 2, 5, 7. So now W is equal to 2, 5, 7. So condition is true. First W can be taken as 2. So brace begin. If visited of 2 is equal to 0. So visited of 2 is equal to 0. False, because here visited of 2 is equal to 1. So this is false. So now this is false. Again control goes to the for loop. Now W can be taken as 5. Okay. So again brace begin. If visited of 5 is equal to 0. So this is false. Visited of 5 is equal to 1. So this is false. So the control does not goes to the if block. Again control goes to the for loop. Now W can be taken as 7. Okay. So brace begin. If visited of 7 is equal to 0. No. This is also false because here visited of 7 is equal to 1. So this is also false. Again control goes to for loop. So now there is no adjacent unvisited vertices of W because 2, 5, 7 are completed. Now this is false. Then control goes to the next statement after the for loop. If stack is empty, no, stack is not empty. Stack contains 1, 4, 3, 5, 7 elements. Okay. So now this condition is false. Goes to the else part. Delete top element from the stack. So now top element is 7. So now 7 can be deleted from the stack. So now whatever the deleted element is there, now call dsearch of 7. So now go to the step 4, dsearch of 7. Now step 4, dsearch of 7. After deleting 7 from the top of the stack, now this is the stack. Now call dsearch of 7. So algorithm dsearch of 7. So V is equal to 7. Brace begin. U is equal to V. 7 can be assigned to U. Now U is equal to V is equal to 7. Next, visited of 7 is equal to 1. Already visited of 7 is equal to 1. There is no need to change. Next, to do, brace begin. For all vertices W adjacent from U. Here U is nothing but 7. What are the adjacent vertices of 7? 7 adjacent vertices are 5, 2, 8. So now W can be taken as 5, 2, 8. So among them, first W can be taken as 5. So this condition is true. Vertex 7 has the adjacent vertices 2, 5, 8. Now first W can be taken as 2. So brace begin. If visited of 2 is equal to 0, as this condition is false because visited of 2 is equal to 1. So that the control does not goes to the if block because this condition is false. Again the control goes to the for loop. Here the for loop, now W can be taken as 5. So now brace begin. If visited of 5 is equal to 0. So this is also false because here visited of 5 is equal to 1. So that this condition is false. Control does not goes to the if block. Again the control goes to the for loop. Now W can be taken as 8. So this condition is true. Let's begin. If visited of 8 is equal to 0. Here visited of 8 is equal to 1. Now this condition is false. Again the control goes to the for loop. So here vertex 7 has no adjacent vertices. So that this condition is also false. The control goes to the next statement after the for loop. If stack is empty, no, stack is not empty. Stack contains 1, 4, 3, 5 elements. So this is false. Again goes to the else part. Here delete top element from the stack. Here top element is 5. Now 5 can be deleted from the stack. So now call dsearch of 5. Whatever the element that is deleted, now call dsearch of that vertex, that is 5. Now we go for step 5. So dsearch. Next step 5. After deleting 5 from the top of the stack, so this is the existing stack. Now step 5, dsearch of 5. Okay. So algorithm dsearch of v is nothing but 5. Brace begin, u is equal to v. So that means u is equal to v is equal to 5. Next, visited of 5 is equal to 1. Already visited of 5 is equal to 1. Next, do brace begin for all vertices w adjacent from u. U is nothing but 5. What are the adjacent vertices of 5? So that can be treated as w. 5 adjacents are 6, 2, 8 and 7. Okay, so now u is equal to 5 and w is equal to 6, 2, 8, 7. 6, 2, 8, 7. So this condition is true. Vertex 5 has the adjacent vertices 2, 8, 5, 7, 6, 2, 8, 7. So now w can be taken as 6, 2, 8, 7. This condition is true. Goes to the body of the for loop. Now first w can be taken as 6. If visited of 6 is equal to 0. Visited of 6 is equal to 0. Yes, condition is true. Visited of 6 is equal to 0. Okay. Now control goes to the if block. Brace begin. Add w to the stack. W is equal to 6. So now 6 can be added to the stack. Okay. Now visited of w is equal to 1. So now visited of w, that is nothing but 6. So visited of 6 is equal to 1. Okay. So now again control goes to the for loop. Now w can be taken as 2. So brace begin. If visited of 2 is equal to 0. So this is false. The control does not goes to the if block. Again control goes to the for loop. Now w can be taken as 8. So this condition is true. Brace begin. If visit of 8 is equal to 0. So this is also false. So the control does not goes to the if block. Again control goes to the for loop. Now w is equal to 7. Brace begin. If visited of 7 is equal to 0. So this is also false. Here visited of 7 is equal to 1 is there. The control does not goes to the if block. Again control goes to the for loop. So now vertex 5 has the adjacent vertices 6, 2, 8, 7. All are completed. There are no vertices that are adjacent of u that are not visited. Okay. Now this condition is false. Again control goes to the next statement after the for loop. If stack is empty, no, stack is not empty. Stack contains 1, 4, 3, 6 elements. This condition is false. Go to the else block. In the else block, delete top element from the stack. Here top element is the stack is 6. So now delete 6 from the stack. Okay. So now call dsearch of 6. Whatever the element that is deleted from the stack, now that element is called by dsearch. Called dsearch of 6. So after deleting 6 from the top of the stack, so now dsearch of 6. Okay. Next, step 6, dsearch of 6. Okay. So algorithm dsearch of 6. Now v is equal to 6. 6 can be assigned to u. So now u is equal to v is equal to 6. So this step cannot be performed. Only at the first time, at the first step, we are using. Remaining cases, we are not using that case. So v is equal to 7, u is equal to v is equal to 6. Because v is equal to 6. Now, widget of 6 is equal to 1. Yes, widget of 6 is equal to 1. Okay. Do brace begin for all vertices w adjacent from u. So what are the adjacent vertices of 6? 6 can contain only adjacent vertex 5. So now u is equal to 6, w is equal to 5. So therefore w is equal to 5. Yes, vertex 6 has the adjacent vertex w5. So now brace begin. If widget of w is nothing but 5, widget of 5 is equal to 0? No, widget of 5 is equal to 1. It is already visited. So this condition is false. The control does not goes to the if block. So again control goes to the for loop. So vertex 6, only the adjacent vertex 5, that 5 is already visited. So this condition is false. The control goes to the next statement after the for loop. This is if stack is empty, stack is not empty. Stack contains the elements 1, 4, 3. Okay. So now this condition is false, goes to the else part. Delete top element from the stack. In the top element in the stack is 3. So delete 3 from the stack. Now the deleted element is 3. Now next call dsearch of 3. Okay. So after deleting element 3, so this is the stack. Okay. Now call dsearch of 3. Okay. Next go for step 7, dsearch of 3. So algorithm dsearch of v is equal to 3. Now v can be assigned to u. So that is u is equal to v is equal to 3. So now this step is not performed. Okay. Next, widget of 3 is equal to 1. Yes, widget of 3 is equal to 1. That is false. So now widget of 3 is equal to 1. Okay. Previously widget of 3 is equal to 0. Now widget of 3 is equal to 1. Next, do brace begin for all vertices w adjacent from u. U is equal to 3. What are the adjacent vertices of 3 that are considered as w? 3 adjacent vertices are 2, 4, 10, 9. Okay. So 10, 9, 4, 2. Okay. So this condition is true. Now w can be taken as 10, 9, 4 and 2. Okay. So first w can be taken as 10. Brace begin. If widget of 10 is equal to 0. Yes, this condition is true. Then control goes to the if block. So add w to the stack. So w value 10. Now add 10 to the stack. Okay. Now widget of 10 is equal to 1. So now w is 10. Widget of w is equal to 1 means widget of 10 is equal to 1. Okay. Again the control goes to the for loop. Now the next adjacent vertex is 9. This condition is true. Brace begin. If widget of 9 is equal to 0. Yes, widget of 9 is equal to 0. Condition true. The control goes to the if block. Add w is nothing but 9. Add 9 to the stack. So now add 9 to the stack. Next, widget of w is equal to 1. So widget of w is nothing but 9. Widget of 9 is equal to 1. Okay. Again control goes to the for loop. Now the next adjacent vertex is 4. So this condition is true. Brace begin. If widget of 4 is equal to 0. So this is false. Already it is visited. So this condition is false. The control does not enter into the if block. Again control goes to the for loop. Next adjacent vertex is 2. So now w is equal to 2. This condition is true. Control goes to the body of the for loop. Brace begin. If widget of 2 is equal to 0. So now this is false. The control does not enter into the body of the for loop. Again control goes to the for loop. So there are no adjacent unvisited vertices for vertex 3. So now this is false. The control goes to the next statement after the for loop. So this is if stack is empty, stack is not empty. Stack contains 1, 4, 10 and 9 elements. So this is false. Go to the else block. In the else block, delete top element from the stack. So top element is 9. Delete 9 from the stack. So after deleting 9 in the, this is the existing stack in step 7. Now D search of 9 is called in step 7. Okay. Now we go for step 8, D search of 9. Step 8, D search of 9. So algorithm D search of B is nothing but 9. So brace begin, U is equal to B. B can be assigned to U. So 9 can be assigned to U. U is equal to B is equal to 9. Next, visited of 9 is equal to 1. Yes, it is already visited of B is equal to 1. It is already visited. Do brace begin for all vertices W adjacent from U. So what is the adjacent vertices of 9? 9 adjacent vertex is 3. So U is equal to 9, W is equal to 3. Okay. Now brace begin, this condition is true. Brace begin if visited of W is nothing but adjacent vertex, that is only 1, that is 3. If visited of 3 is equal to 0, no. Visited of 3 is equal to 1. So this condition is false. The control does not enters into the if block. Again control goes to the for loop. Okay, there are no adjacent unvisited vertex for U, that is vertex 9. So this condition is false. The control goes to the next statement after the for loop. If stack is empty, no, stack does not empty. Stack contains 3 elements, 1, 4, 10. So this condition is false. Go to the else block. In the else block, one statement is there. Delete top element from the stack. Top element is 10. Delete 10 from the stack. After deleting 10 from the stack contains only 1 and 4 elements. So whatever the element that is deleted, that can be called D search of 10. Okay. Now go for step 9, D search of 10. Okay. So algorithm D search of 10. So U is equal to B. 10 can be assigned to U. Now U is equal to B is equal to 10. Next, visited of 10 is equal to 1. Yes, visited of 10 is equal to 1. Next, do brace begin. So what are the adjacent vertices of 10? U is equal to 10. 10 adjacent vertex is only 3. Okay, only 3. So now U is equal to 10 and W is equal to 3. So now this condition is true. 10 contains the adjacent vertex, that is 3. So this condition is true. The control goes to the body of the for loop. Brace begin if visited of 3 is equal to 0. Visited of 3 is equal to 0. False. It is already visited. So this condition is false. Then again control goes to the for loop. Okay, there are no adjacent vertices for 10. Okay, again this condition is false. The control goes to the next statement after the for loop. So if stack is empty, stack does not empty. Stack contains 2 elements, 1 and 4. So this condition is false. Go to the else block. Delete top element from the stack. So in the top of the stack, element 4 is there. So now 4 can be deleted from the top of the stack. Okay, after deleting 4 from the top of the stack contains only 1 element, that is 1. So now call D search of 4 because deleted element is 4. So now call D search of 4. Okay, next step. D search of 4. Algorithm D search of 4. V is equal to 4. Now V can be assigned to 2. U is equal to V is equal to 4. Next, visited of 4 is equal to 1. Yes, already visited of 4 is equal to 1. Do brace begin. Find out the adjacent vertices of 4. So U is equal to 4. 4 adjacent vertices are 1 and 3. So now U is equal to 4, W is equal to 1 and 3. So this condition is true. First W can be taken as 1. Brace begin. If visited of 1 is equal to 0, this is false. Again control goes to the for loop. Now W can be taken as 3. So this condition is true. Brace begin. If visited of 3 is equal to 0, this is also false. So the control does not enters into the if block. So again control goes to the for loop. So vertex 4 has the adjacent vertices 1 and 3 that are already visited. So now this condition is false. The control goes to the next statement after the for loop. If stack is empty, no, stack is not empty. Stack contains one element. So this is false. Control goes to the else block. Delete top element from the stack. So now top element is 1. So 1 is deleted from the stack. Now D search of 1. Call D search of 1. So now D search of 1. So algorithm D search of 1. So now 1 can be assigned to U. U is equal to V is equal to 1. So next visited of 1 is equal to 1 as it is already visited. So now do brace begin, find out the adjacent vertices of 1. 1 adjacent vertices are 2, 4, 3. Here 2, 4, 3 and 3. 2, 4, 3. So condition true, brace begin. Now first can be W is equal to 4. Okay. If visited of 4 is equal to 0, false. It is already visited. The control does not enter into the if block. Again control goes to the for loop. Now W is equal to 2. Brace begin. If visited of 2 is equal to 0. So this is also false. The control does not enter into the if block. Again control goes to the for loop. Next W is equal to 3. So now this condition is true. Brace begin. If visited of 3 is equal to 0. This is also false. The control does not enter into the if block. Okay. Now there are no adjacent vertices of vertex 1. 4, 2, 3 are already 1 or 3 is not there. 4 and 2. Sorry. 4 and 2. So 4 and 2 are completed. There are no adjacent vertices of vertex of 1. Okay. So now this condition is false. Again control goes to this one. If stack, next statement after the for loop. If stack is empty, yes, stack is empty. There are no elements are there. So this condition is true. Then return. Okay. So after returning that one, so this algorithm is terminated. So now this is the D search sequence. So 1, 2, 1, 2, 8, 7, 5, 6, 3, 10, 9 and 4. Okay. So this is the D search sequence, D search traversal sequence for this graph. Okay. So in this way, we have to find out the traversing order of a given graph by using D search. D search means depth search. Okay. So thank you for watching this video. So this video take more time. I am explaining step by step. Whatever I am explaining, I am writing this one. Okay. So because of that reason, it can take more time. So if you like this video, please subscribe my channel name. So DIVVELA SRINIVASA. DIVVELA SRINIVASA. So please forward this video to your friends and classmates. So thank you.